All right, so I'm Jeremy Wolf. I'm one of the product managers on VCF. I'm primarily focused on that consumer experience. Really, how do we take infrastructure and make it something that is self-service, something that we're able to expose to anyone who wants to be able to consume this infrastructure. So first thing, you've heard about VKS, you heard about the Kubernetes service specifically. You also heard about some hints at some other runtimes that we have. Not just runtimes, but some other services that we're able to leverage. The key thing here, and I don't think this is a surprise to anyone, right, is apps require a lot more than just a runtime. They need more of an ecosystem that functions around them so that when whoever the consumer is, whether it's a platform operator or an app developer, they're able to deploy their workloads and they're able to leverage the ecosystem that is around them to be able to move very, very quickly, right? That's the primary goal here. So when we think about what makes a cloud typically successful, it is really that ecosystem that exists around the different runtimes they provide. I mean, look at any of them, they have some core runtimes that they focus on, but then there's always an ecosystem of services that exist around them. So I want us to keep that in the back of our mind as we kind of go through these slides. So another variation of some slides you've seen already, but primarily the idea here is that VCF, it is about bringing a cloud to your private data center. And when we say cloud, we truly mean that. We're talking about a space where you're able to deploy new workloads, you're able to deploy new services that's immediately extensible. It can be altered to meet the needs of your specific lines of businesses. And we want it to be able to be multi-tenant safe so that tenancy is built directly into the ecosystem. So we heard about VKS. VKS is just one of the runtime services. We have 3 primary core runtime services that are out of the box available to any consumer of VCF. They're going to be the VKS service that conform with Kubernetes clusters. It's going to be the VM service. And just to call this out, VM service is just a new way to consume and manage vSphere virtual machines. They are real vSphere virtual machines underneath the covers. They get deployed into ESX, but the idea here is to be able to allow consumers to interact with it in a cloud-like way with a lot of governance and policy placed around them. We have the container service. This is based off of a technology that we use called vSphere pods, but it is exactly what it sounds like. The ability to deploy a container into a ecosystem without the need for a full Kubernetes cluster. I don't need management, or I don't need control plane VMs. I don't need worker VMs. I just have an image. I want you to deploy it. I want to provide some limited input around config maps, secrets, resources, and then I want to be able to scale it. But I do not want to have to worry about a Kubernetes runtime. I just want to worry about the deployment of that container.
Hold on, you're saying config map secrets?
Yes.
You're also saying this is not Kubernetes.
So the idea is if you go look at the public cloud, there are some container services that exist out there. They will typically have concepts like config maps and secrets, right? But they don't expose it in the same way. What you'll see here is everything that we do from a platform perspective is done through custom resources. So a lot of the terminology is going to be similar. We're going to use them the same way. But the intent is I don't want people to walk away with the idea that the container service is Kubernetes, because you're going to immediately think it's a Kubernetes runtime, therefore I have these expectations of it, right? In this world, these containers, they operate in a multi-tenant ecosystem. That means there's things that I inherently as a consumer am not going to be allowed to do. I'm not going to be able to create cluster scoped objects, right? Because those are going to be things that can't be multi-tenant controlled, right? I am going to want to be able to lifecycle manage things in a very specific way when it is Kubernetes based. So our intent is to abstract away a little bit of that concept, leverage the capabilities that we believe are extremely powerful in the Kubernetes system, but focus more on the outcome that you are desiring, which is the ability to deploy a container. And we can obviously in later times go into a little bit more detail here, but there's a lot. Yeah, go ahead.
So it's not Kubernetes, or it is, but it does support CRDs?
Yes. So
okay, can you give me one step layer deeper?
Yeah. So in just a little bit, I have a slide that will describe some of this, but like the idea, you've heard hints of it. We had the vSphere supervisor. The vSphere supervisor is our declarative API service. It is Kubernetes. It's made up of 3 control plane VMs. And then what we do is we end up turning all of the ESX hosts into worker nodes. But that when we say worker nodes, it's really just worker nodes for these the container instances. Everything else is going to go through the back-end technology like DRS and vSphere HA and those types of vSphere structures in order to deploy and manage virtual machines. And so that declarative API surface, it is the way we are going to expose all these custom resource definitions. And you're going to hear a lot of that. There's two layers, okay? So I will refer to the declarative API service. When I'm referring to that service, I'm talking about the platform, and I'm talking about the cloud services that are deployed there. And then anytime we talk about conformant Kubernetes, we're talking specifically about clusters deployed via the VKS managed service.
Can you just for a second talk about like what customer demands drove that compared to, because it seems like the industry is a hammer now right now for everything Kubernetes, right?
Yeah, so a lot of it came down to the fact that we believed in the model of we need to be able to provide managed services. That's at the core, meaning that I want to be able to make it so that someone can take a service, a VI admin, can take a service, bring it into the ecosystem, and then expose that service in a very common way. The common way we decided was custom resource definitions. And you'll see why we see a lot of this benefit here in a second. But by doing that, it immediately started to align with ways that people expect to consume workloads. Then we had the added advantage that it's declarative in nature, it's desired state-based, and so there's a lot of synergy that we can get out of that ecosystem. And so really, when we kind of dive into this, every single one of the services you see here are consumed through this same model. It means that unlike previous vSphere ecosystems or VCF implementations, it's always been, hey, we have a cloud platform. That cloud platform has, say, 6, 7 services that you can consume on it, but they all have their own APIs, which means you have to go interact with 10, 12 different APIs. You need to be a subject matter expert in all those APIs in order to weave them together in order to get a cohesive story.
I promise this is my last question, but I lived through I saw the company Docker and the Swarm and the Rancher. Is this sort of born out of that approach that we wanted lighter weight but still containerized?
That is definitely some of it. Okay. Yeah, and it's kind of interesting because when you look at it strictly from Kubernetes for Kubernetes' sake, right? There's kind of a doctrine that exists there that states, hey, if you're going to do it, go all the way in.
Yeah.
But the reality is, like, when you go talk to customers and you see kind of where they're at in their like transition from, I am doing like legacy-based deployments, I understand containerization, but I'm not quite ready to go full cloud native.
Yep. Like
there needs to be an intermediate step, and this container service definitely fills that space.
So I'm trying to track all this and figure out the hierarchy. You said there was 3 services that sit on top of VCF.
Yep.
But did you say the other 4 were parallel?
So I will draw a line. So if we were to look at the screen, we have the three first boxes. So VKS, VM service, container service. Those are the runtime services.
Okay.
Then to the right of that, we have storage, we have networking. Those are also like core capabilities. They are direct integrations with the vSphere ecosystem. And that when I say the vSphere ecosystem, what I mean is it's interaction with like vSAN, it's interaction with ESX, vCenter, NSX, those technologies. And we'll see a description of this here in just a second. But the idea is like we're bringing this capability so that you don't have to understand the infrastructure that exists underneath it at all. We want a complete abstraction. And so we have those kind of core infrastructure capabilities, but then we also have things like, backup and restore. It's something that's necessary in the ecosystem. We have it both from a platform perspective, so I need to back up and recover the entire platform. We also then have the service that can be exposed for consumers to be able to leverage backup and recovery. And then kind of going into this a little bit deeper, we have things like Harbor, our OCI image registry. We have Argo CD. We have our secret store. We have a lot of operators that we're going to see coming into this ecosystem. And one of the key things here is because we have this single declarative API service and it's multi-tenant safe, we can now leverage the Kubernetes operator custom resource definition pattern to create operator factories that will create those dedicated instances for consumers. So now as an admin, I can introduce a new service to the ecosystem. That new service will then be able to be leveraged inside of those namespaces directly.
So the 3 to the left are runtime, and what did you call the other?
3 to the left are runtime. The ones to the right would be primarily core infrastructure and add-on services.
And why wouldn't you put those below the run?
Probably should have.
Okay.
Yeah. So there's another, there are obviously lots of iterations of this, right? And there's a couple of views of this where we have runtime, and you've seen it in Will's session. We had runtime kind of on the top, and then we had service integrations on the bottom, or the core infrastructure integrations on the bottom. That was networking, load balancing, storage. And then on the right side, we had a bunch of add-on services. Those add-on services are those bring them into the ecosystem to extend the capability.
Okay, I think I get it.
All right, so just the visualization. So I told you that every single resource that's deployed into the VCF ecosystem is consumable via Kubernetes APIs. So every time a service is introduced here, it's introduced in the same model of API version kind. I can do a kubectl explain on a resource. I can see all of the different capabilities that are available to me. And I can use those native Kubernetes constructs to be able to explore what's available. So to the CLI example, right? We have kubectl, it works here, it does, right? We also have the VCF CLI. So the VCF CLI is modeled a lot like what the public cloud CLIs look like, where there will be a CLI, it will allow me to log into the infrastructure, but then there'll be a set of plugins that I can leverage that are specifically designed to interact with these resources. So I can deploy virtual machines and explore virtual machine constructs. I can deploy object storage and explore those constructs. But a key thing here is just understanding that every time that we bring a service into this ecosystem, it's going to follow this model. Because when we talk about the VCF automation experience, where I'm this VCF cloud, where I'm in the VCF cloud and I'm going to go into and consume the infrastructure, a big problem that we have in private data centers is when I add a service, how do I tell people that a new service is available to them? I have to kind of evangelize that solution and get people convinced that it's something that is available to them. Here, it just shows up in their experience, whether it's the CLI or the UI, it's there as soon as I deploy it.
Is there a reason you didn't have the container service on that screen? Is that what it meant?
No specific reason other than underneath the covers, it's just using standard Kubernetes constructs. So version 1 pod as an example, right? Use deployment, stateful sets, all of those things.
Well, and I'm really confused on how these two map together, because the secret store service is on the other one was above the other.
Yeah. So
I'm just trying to figure out how these relate to each other and what supports what and what's.
Yeah. So a good way to think about this is in a vSphere namespace, I can deploy these runtimes. So the 3 runtimes, those will be where my workloads are running. They'll be able to leverage services that are in the ecosystem. Those services are the services that are around this, right? I can leverage Argo CD to do those deployments. I can leverage the storage service via persistent volume claims, or as was announced during Explore, I can use integrated file service. I can use object storage, which will also be exposed through those. And so the idea here is as I'm deploying those runtimes, I'm able to use these same resources through the same API. And so I wouldn't really think of this so much as like stacks, right? It's Lego blocks within the same bucket, and I'm picking those Lego blocks up and I'm building out my application, my workload requirements. And then underneath the covers, we are going to handle that experience from an integration perspective.
And you left Argo off the previous slide because
it's just a lot to add into the slides. So Argo here really is just that orchestration tool, right? So how are we going to have a manifest-based deployment model, right? Because that's what all this is going to be based off of, all YAML. How do I then take that and put it into an automated solution? And the key thing here is like Argo, you've seen an instance of it deployed, but the reality is that Argo instance is backed by a custom resource. And it's not just backed by a custom resource for the Argo instance itself, it's backed by custom resources for all of the key Argo objects that you would want to be able to interact with the intent being that I can fully automate and repeat that deployment without the need to actually go into the individual application. All right, so Will talked about this just a little bit, but I just want to hone in on it one more time, is Underneath the covers here, we have that vSphere supervisor. The vSphere supervisor has a construct called a vSphere namespace. Like, I want to emphasize that while this is like a namespace, it is quite a bit different than a namespace. It acts as a true hard tenancy boundary. It is where we isolate compute, we isolate storage, we isolate network. It's where we manage quota, meaning that we can assign quota at the CPU level, at the memory level, at the storage level. And when we get to the storage level, we actually can go even deeper than that. We can go down to storage class variations. So we're able to do that, but we also have the added advantage here where I can use the vSphere namespace, because it's a tenancy boundary, to do content restrictions. So I could say, hey, this specific vSphere namespace that is owned by or is going to be used by my dev team, that dev team, they're only going to be able to be allowed to deploy the newest versions of VKS. So we're going to Kubernetes release control here. We are going to be able to do VM image control here. So we're going to say, hey, you can only use Ubuntu version 22.04 as an example. We also have VM classes. We didn't really touch on it too much here, but just like in the public cloud, there are t-shirt size variations of VM infrastructure, because the primary problem here is a lot of developers don't really understand hardware. They don't understand infrastructure. They shouldn't. They should just be able to understand how many CPUs do I need, how much RAM, do I need accelerators, and then be able to pick it from a list. Go ahead.
This is all VXLAN based still, right?
Say that one more time.
VXLAN, the NSX.
Yeah, so this is all NSX based.
And that's still VXLAN.
Yeah, so we do support VDS based networking.
Okay.
But there are experience issues in that space, because VDS is not very cloud-like. It doesn't expand very well. And so when we talk to people, we specifically say, hey, pick up the VPC. Because NSX plus VPC, you get a cloud network model, meaning that I have these subnets that can be referenced based off of what kind of routability I need. And I, as an app developer, platform engineer, I don't really need to know the details. I just need to understand the outcome I'm going to get out of those networks. All right. And this slide I probably should have led with, according to the conversations we had. But so the idea here is we have two things that we get from this model of a declarative API surface that is Kubernetes based. It is our vSphere supervisor. That's what it's called under the covers. Two big things we get. One of them is we get this abstraction from infrastructure. So one of the big difficulties of running Kubernetes in a virtualization layer is, like, how do you control the versioning and interoperability of all of the different integration endpoints, right? Whether it's networking, whether it's storage, whether it's compute, whatever it is, like, you have to manage those things individually. And in this world, in VCF, you just worry about the supervisor. The supervisor is the thing that's going to interact and interoperate with all of those underlying systems. So that's one big advantage you have here. So now you just worry about the versions of Kubernetes you want to provide from a consumer perspective. You worry about the services you want to provide. And then all of that infrastructure interoperability happens through the supervisor layer. The second piece that we get here is there is no need to have privileged access to any of the infrastructure resources. vSphere namespace is multi-tenant safe. It's multi-tenant safe because we do not have to provide any username or passwords, any service accounts. We don't have to worry about any of that integration. All we do is we use the Kubernetes watcher pattern, where we watch for requests to hit the API server, and then our controllers behind the scenes watch for those requests and then go execute that on behalf of the user. And so this model we call the para-virtualized model, and it is how we continuously will develop and deliver this abstraction as well as this security model. So a quick demo. I have a much longer demo, but we probably do not have time for that. It's a variation of what Will showed. We have a three-tiered apps are kind of lame now, but it's a good example of how you would use an ecosystem like this, where I have virtual machines and I have Kubernetes. I need to run them together. Like, how does that look? Like, why would I want to use a declarative API surface? What are the advantages of using a single API surface to do this? So we have a simple three-tiered application, and the basic breakdown here is we're going to deploy a MySQL database inside of a virtual machine. We're going to deploy that virtual machine via the VM service. So just some quick highlights there is the VM service is going to, it's going to be a standard vSphere VM. It's going to be deployed and managed via this Kubernetes interface. And it's going to use Cloud Init in order for us to actually configure that MySQL configuration. So we're going to deploy MySQL there. We're going to seed the image or seed the VM with some data, and then we're going to actually operate that database. We're going to deploy a VKS cluster. The VKS cluster is then going to have a front end and a back end application deployed to it. The difference there is that the back-end application is going to be responsible for communicating with the database, and the front end is just that. It's going to be the UI that's going to be responsible for communicating requests back to the back end. But we're going to leverage all of the services you see up top. So we can use the secret service to store our database configurations. We're going to use the volume service to have our persistent volumes. We're going to have our network service providing the network capabilities, and this is oftentimes kind of the unsung hero here is network. In this, you're going to see it just happens, right? We don't have to worry about it because it's just part of the platform. And we get to be able to leverage all of those capabilities. And then finally, we're going to use the VM image service, which is where we're going to be pulling that Ubuntu image. And we're going to be using that with our VM service. So we're going to see all of this kind of come together. So the first thing, we're going to make some assumptions here. You already seen how Argo CD looks like. It's already deployed into my vSphere namespace. I have already taken all of the deployment manifests and I placed them in source control. When I say deployment manifest, I mean my VKS manifest, my VM service manifest, my application manifest, so the front end and back end deployments. I have placed all of that inside of a Git repository. And I have also placed in that Git repository an Argo application YAML. So here's my Argo application YAML, and it's going to be an apps of apps relationship. So I'm going to deploy this, and it's actually going to deploy 3 other Argo CD applications. So one of them is going to reference our VM deployments for our database. The second one's going to be our VKS cluster, and the third one is going to be that front end and back end deployment inside of the VKS cluster. So here we'll see an example. This is the VKS manifest, and it's literally the manifest that was inside of that UI being made on the right side. We just stored it in source control. So here we pasted the application YAML, and now we're going to see Argo do its magic, right? So it's going to deploy those 3 applications, and our desired state is going to be achieved here. So we have our VKS cluster. If we were to kind of dive into this, we could actually go in and start exercising some of those GitOps models. So we could go into our source control, we could scale the number of worker nodes associated with this VKS cluster. And those worker nodes would then be able to be rolled out. And if someone went in and tried to adjust or control something locally on this cluster or make changes to it, our Argo instance is going to automatically go override it. So we get this really strong declarative experience. So that is the end of the demo. So I have 4 minutes.
Right.
I have, like I said, a much longer demo if you want to see more. Go ahead.
So the hammer nail with like Kubernetes is the upside of that is maintainability. This seems like it would be very difficult to troubleshoot, particularly if I'm running my MySQL on a VM. I might be running separate containers and container services, and then I might be running VKS. It just, to me, screams of a sort of a maintenance and supportability and troubleshooting nightmare.
Yeah, I mean, anytime you are deploying a lot of different application form factors, there's complexity that comes out of it, right? What I'm not recommending is that you do that. What I'm saying is if you have a need to do it,
Okay.
you can.
Okay.
And you could do it through the same API service. And the reality is, like, you could even have some intermixed modes here where you use that namespace construct to be a boundary for different types of deployment models, right? And the key here is it's all available. You use it where you need to use it. And the key here is, as Will showed, is all of this is then ported up into VCF operations. And you're able to see all of the capability through the same layer.
And then the counter argument to that, the upside is because you're using all the API, the CRD API, then at least from a discoverability, everything's the same. Is that?
Yep.
Okay, good. All right, thank you.